Good evening, everyone. Myself, Sridhar, and from CACF section. And for the subject web system engineering, my top and the AD Tech Talk, my topic is about service-oriented computing, a trajectory for research to 2030. Here we can see the introduction to service-oriented computing. The service-oriented computing (SOC) is a paradigm that organizes distributed software system as interoperable services. So it aims to enhance flexibility, reusability, and scalability in complex computing environments. The trajectory for research to 2030 focuses on evolving SOC to meet emerging technological and societal needs. Here, the SOC, the service-oriented computing, is basically a distributed or software system which is interoperable service. Here we have many things in this service-oriented computing and system integration, such as artificial intelligence, big data processing, cloud computing, service and web programming, and also the technologies we have. These are the technologies and application. We are also having some of things uh, in like mobile and IoT devices and ADS, DBVS, and RAS, etc. These are the technologies we do have in the service-oriented computing. The historical context and evaluation. The service-oriented computing SOC emerged in the year 2000s as a response to the limitations of monolithic application architecture. Over time, it integrated with cloud computing, microservices, and edge computing. Future research will focus on unifying these paradigms for seamless service integration. So basically, the SOC is emerged in the 2000s, early 2000s, which is like having to be as a response of the monolithic application architecture. Monolithic application architecture, which is nothing but it's a layered architecture, which is having a single layer architecture. To overcome this single layer architecture, this service-oriented computing has come into picture, which later integrated with an cloud computing, the microservices, and also the edge computing. The current state of service-oriented computing. The present SOC systems emphasize interoperability, dynamic discovery, and composition of services. Key standards include SOAP, REST, and WSDL, facilitating communication and services. Description. Here, the challenges remaining in managing heterogeneity, security, and quality of service in a large-scale deployments. In today's environment, the SOC is emphasizes as an interoperable dynamic discovery composition of services. Here, the key research challenges: ensuring secure, trustworthy, and privacy preserving service interactions is critical, which is the most important key research challenge. And also, then managing complexity and ensuring reliable adaptive service compositions remain ongoing challenges. Addressing scalability and performance, increasing distributed environments is essential for future SOC. Here, these are the key research challenges which are like having a scalability in the performance and increasing some distributed environment, and also having the managing complexity and ensuring the reliability, which is the most important, and also having the preserving the privacy, which have with a service is most critical. Emerging technologies impacting SOC. The rise of artificial intelligence (AI) and machine learning (ML) is enabling intelligent service discovery and composition. Edge and fog computing expand SOC to support real-time processing closer to data sources. The blockchain technology offers new ways to enhance trust, security, and transparency in service interactions. Here, the emerging technologies impacting the SOC are like the artificial intelligence and the machine learning. It's the most important. It's a intelligent discovery and composition. Then we go with the future research directions from now to 2030. In this 4 years of span, developing adaptive context-aware services ecosystem that respond to dynamic environments, creating standardized framework integrating AML compatibilities in services seamlessly, exploring self-organizing and self-healing services architectures to improve resilience. Here we can see that the service oriented computing is an cycle where it having a service client and also a service provider. The service registry is a intermediate between the service provider and the service client. This service provider having a web service which is published to the service registry, which is like binded to the service client to find its needs. And then intelligent service discovery and composition. Discovery the research will focus on leveraging AI to enable autonomous, efficient service matching and composition. Efficient service matching and composition. The we are having here such as semantic technologies will play a vital role in understanding services, compatibilities, and context. Dynamic real-time adaptation of service workflow will become more relevant. And then we go with the security, privacy, and trust in SOC. Here, the future SOC systems must incorporate advanced security mechanisms to protect data and services. Privacy preserving techniques such as federated learning will be integrated in service ecosystems, blockchain, and distributed ledger technologies will enhance the trust auditability. Then stability and performance optimization. Here, research will address scalable architectures for handling massive volumes of services and interactions. The techniques like edge computing and microservices will be optimized for high performance. Adaptive resource management will ensure quality of service under varying load conditions. Yes, the scalability and performance is most important for the as an it has an for SOC because it's a service or oriented computing where it has to provide the service which should be as a scalable with us having a proper address scalable architectures and also having a good performance optimization, which is most important for these service oriented computing. Societal and ethical considerations. The future SOC, the service oriented computing research, must consider ethical implications of autonomous services and AI integration. Ensuring inclusivity and accessibility of services will be a key goal. Addressing data governance and compliance with regulatory frameworks will be integral. Here, the most societal and ethical consideration for this SOC are like integrating the AI and ML, which is like artificial intelligence and machine learning into the SOC, so it can improve the optimization and the performance, and also has a scalability, which is like implementation or implications of the autonomous services, and also the AI integration is most important, and also ensuring these inclusivity and accessibility services will be a key goal, and these can be a better option to provide a services by using this service oriented computing will be a most important step that they can do. Interdisciplinary collaboration and ecosystem. Collaborations across computer science, business, and societal domains will drive innovation. Building open interoperable service ecosystem will foster widespread adoption. Cross-disciplinary standards and best practices will be essential for cohesive development. Here, that's most important for the collaborations across the computer system sciences and also have business and societal domains will because the innovation come from every place. So it's collaborating at in any other domains will be most important for the more newer innovations in this service oriented computing. Education and workforce development. Preparing the workforce with skills in SOC, AI, and cybersecurity will be vital. Academic circular must evolve to include interdisciplinary training on service-oriented paradigm. And also lifelong learning initiative will be support professional adapting to technologies advancement because this the lifelong learning initiative is the most important initiative which can be professional adaptive. So technology as we have evolving this modern era, we need a lifelong learning because we are like many of the new technologies has been booming and evolving, so we have to know about each and everything So it's a lifelong learning initiative is will be the most important for the professionals. And then industry and commercialization opportunities. Industry adoption will accelerate with the development of robust standardization of SOC frameworks. New business models will emerge around service markets, places, and ecosystem. Collaboration between the academia and industry will be the key to translating research into the practical solutions. And also vision for 2030. By 2030, SOC will underpin pervasive, intelligent, and a trustworthy digital ecosystem. Autonomous service management and seamless integration will commonplace. A continuous innovation will be driven by the emerging technologies and societal demands. So here there are some of the references such as the service-oriented computing concepts, characteristics, and direction, the communication of ACM. And this is all about the service-oriented computing. And thank you.